Hi everyone, Tech and HSR here today. We're going to walk you through the AI Research Navigator, which is a free tool that helps you determine what type of IRB review is needed for your AI research project, or even if IRB review is needed. Again, this is just for AI projects, not your normal non-AI research projects. So in about 7 minutes, we're going to show you a real scenario from start to finish. So let's jump right in. All right, here's our scenario. A research team is developing an AI algorithm. Eventually, they hope the AI tool will be able to predict sepsis risk from vital signs. They want to validate it using retrospective patient data from their EHR, and they're planning to publish their findings. So let's see what pathway the tool recommends. And this is your tool. So I'm going to have to say I'm ready and let's start. All right. This will show you how much you're completing. 9 questions, 11% complete. All right, so the first question is asking if we are testing an investigational AI device for safety and effectiveness. So notice the tool explains this in plain language. So this is not regulatory jargon. In other words, hopefully you can tell by now that this is supposed to be a research-friendly tool because we want to make sure that we get the information we need right at the start. So it's asking, are we proving the AI works or are we using an already validated tool? So in our case, we're validating the performance retrospectively, and we're not yet testing it on new patients prospectively for that safety and effectiveness. So here we are going to click no. We are not testing safety and effectiveness yet. Question 2, are you establishing clinical association? So this is the first stage of the 3-stage framework. If you haven't read on that, that is part of the initial training. But see how it breaks down the concept with expandable sections, right? So we've got what is clinical association and then what is the stages here. This is where we establish whether there's a valid medical connection, stage 1, right? Clinical association. Establishing a valid medical connection between what the AI detects and an actual clinical condition. So in our scenario, we're establishing that the vital sign patterns can potentially predict sepsis. Now that's what we're trying to prove, is that clinical association. But we're also validating performance on data. So we're actually moving more into stage 2, and we're not just in stage 1. So I'm going to select no here because we are actually beyond stage 1 discovery. We may not be in deployment yet, but we're beyond stage 1. Okay, are you validating performance in stage 2? So this is a critical question that trips up many researchers. Notice the title doesn't say for a medical device. It's just asking if you're validating, right? We're asking about the tool's intended design or intended use. So look at this detailed section. What is intended use? I'll give you a second. So it's not about how we're using the tool in this specific study. It's actually about what the tool that you're making is fundamentally designed to do. So in this case, our sepsis predictor is designed for clinicians to use for risk assessment that triggers a clinical action. That's what we hope it will do. That makes it a device under FDA's definition, regardless of whether we're calling this project research or quality improvement. Right now, all we want to know is it a device? And that's what we're focusing on right now. First steps first. So if we see these FDA 2026 CDS guidance, then it's going to walk us through 4 criteria Here's the criteria. Okay. And if we evaluate our tool based on the intended use, what we're designing it to do, then we see that our tool might pass all of the first two criteria, but it's actually failing criterion 3 because it is providing time critical alerts and patient specific recommendations. And so, therefore, it does constitute a device. So, because of that, we cannot call it a non device. And therefore, we are going to check yes, this tool is designed for clinical use. Okay, now device validation. Now we know we have a device. Now we have to do device validation. It's telling us something important. Validating a medical device requires a full board review so that the board can make an SR/NSR determination. In other words, that significant risk or non-significant risk determination. The board has to make that determination. It cannot be done under an expedited review. So even though our study is minimal risk and it's just testing offline, meaning it's not impacting patients, it's not in medical records systems, right? It's offline and it's essentially retrospective, still requires that full board because 21 CFR 812 does require that board make that determination. But after initial full board review, the board may determine that moving forward, for example, under continuing review, that review can be done in an expedited manner, meaning it doesn't have to go to full board anymore unless something changes. So now we've made that device determination, the initial review determination, but now we have to say, okay, well, is this, I want to do a double check and see, is it actually research or is it quality improvement? So let's go ahead and continue to determine if it's research or quality improvement. Because if it's quality improvement, then actually the board would not make that NSR determination because it would not even go to IRB review. So let's see if that now has to happen. So this is pretty straightforward in our scenario, but it's not always straightforward. In ours, we plan to publish findings and share the algorithm with other institutions. So basically, yeah, generalizable knowledge, which is defined under 45 CFR 46. If we were just fixing like our local sepsis alerts, maybe that we have in Epic, and just keeping it internal, then we would consider its quality improvement. But here we know we are trying to contribute to the field, so we're going to go ahead and click research because we want to create knowledge that other people can use for publishing. Now the next one is your AI human-centered? So does our AI mimic human decision making? Absolutely. It's predicting clinical risk the way a clinician would. If it were just optimizing server performance, it would be a technical infrastructure and therefore it wouldn't be human decision. Human subjects research. So as you can see here, now we're finally getting to that. Is this human subjects research? We know we have a device and now we know we have research, but is this human subjects research or is this non-human subjects research? So that's what we're trying to get at this question. And for ours, it's our tool is predicting clinical risk the way that a clinician would using human data. And so if it were just optimizing for server performance, then maybe we would just say like, no, it's purely technical infrastructure, but we definitely have some clinical decision support functionality going on. So we're going to go ahead and click yes here, mimicking human decisions. Question 6, does this involve identifiable people, right? So, okay, now we also want to know if the data is identifiable, right? Because that's also part of the human subjects definition. So here's where the tool addresses a major misconception. So you notice that the first thing it starts out talking about is synthetic data, and that it does not automatically mean anonymous if that's what you're doing. And the reason why we bring this up is because a lot of people think that as long as they're dealing with anonymous data, then they don't have to go through the IRB and they don't have to go through any FDA considerations. So that's something that we wanted to address straight up front. Um, for our scenario, we used retrospective EHR data, so synthetic data is not relevant. We do have identifiable data. And so for our retrospective EHR study, right, then we would go ahead and say, yes, this data involves identifiable people, or it has re-identification risk. Okay, now the final question, what stage of the AI research development are we in? So we know we're doing offline validation, so we're not trying to put this into our medical record system just yet. We're not trying to make any impact on patient care just yet. We're just doing this offline validation of what we now know to be a medical device. And so that's stage 2. So notice there are now separate options for medical device versus non-device stage 2 work, right? This is because sometimes we might have a non-device, non-medical device that we also want to validate. So here we're definitely dealing with a device offline and under stage 2. So we're going to go ahead and click that one. All right, so here is our final determination. Full board is required. Notice how it explains what this means in plain language first, and then it provides the regulatory framework. So you see all these CFR citations, 21 CFR Part 56, 812, 820, Part 11. It explains the NSR, SR determinations. So essentially, if you do get an NSR determination, if the IRB determines that the device is non-significant risk or NSR, then that would require an abbreviated IDE. So the IRB becomes the FDA surrogate and no formal FDA application would be needed. So we scroll down and essentially this is our journey where every choice that we made and the regulatory reasoning is all here. And so this is essentially the perfect documentation for an IRB submission or an IRB determination and how you reach that determination. And then at the very bottom, we have the NSR a determination explanation at the bottom. And then as you can see, you can actually download this as a PDF so that you can upload that into your records. And so there it is. You will just use this either as an IRB making a determination after you read the protocol, or a researcher can use this to evaluate it on their own and provide the IRB supporting evidence for their determination, which eventually the IRB has to confirm anyway. So that is the tool.